Solutions for quiz 7, math 111. So the first question here asks you to list all the possible rational roots of this polynomial. To do that, what you need to know is that the possibilities for rational roots are factors of the constant term divided by factors of the leading coefficient. In other words, they take this form, let's just say 6, and then I'll throw the plus or minus out in front of the whole thing. In other words, let's see, factors of 6 are 1, 2, 3, and 6. Sure. 1, 2, 3, and 6. And factors of 2 are 1 and 2. So my possibilities are plus or minus 1 if I do the 1 divided by 1. Plus or minus 2 if I do 2 divided by 1. Plus or minus 3, 3 divided by 1. Plus or minus 6, 6 divided by 1. Plus or minus 1/2 if I do this 1 divided by this 2. 2 divided by 2 would be 1, but I already got that on my list. 3 divided by 2, plus or minus. And then finally 6 divided by 2, but that's just 3 and it's already on my list. So here's all your possibilities. What do I got there? 1, 2, 3, 4, 5, 6, 12 possibilities. There's 12 possible rational roots of this polynomial. Okay, now it says test until you find one that works. My advice to you that I gave you in class was always test 1 and -1 first. Typically one or the other will work. So let's test 1. Maybe I'll write that. Test x equals 1. The way you do that is you put 1 into the function and see if 0 comes out. If 0 comes out, it's a root, right? Roots are x-intercepts. Real roots are x-intercepts. So if 0 comes out, I know that this one worked. If it doesn't, I continue searching. So let's try it. Change all the x's into 1s. You get -2 times 1 cubed minus 2 times 1 squared plus 10 times 1 minus 6. I got -10 plus 10 gives me 0. Look at that. One worked right off the bat. Test the possible roots until you find one, until you find an actual root. X equals 1 is a root. Really, this line would probably be fine, but I'll write this just for the solutions. Use polynomial long division and factoring to find the factored form of our polynomial, which I guess we're calling g. Well, if 1 is a root, what you need to know, a very important fact, is that x minus 1 must be a factor. 1 is a root of the polynomial, x minus 1 is a factor of the polynomial. So I got x minus 1 divided by -2x cubed minus 2x squared plus 10x minus 6. Note, -2 divides into all of these terms, so I could have factored out -2 before I did polynomial long division. I imagine most people did not think to do it that way, so I'll do it the way I imagine most of you will do it and factor out that -2 next. But just in case you saw that, you were completely right. I want to get rid of this -2x cubed. I'll throw a -2x squared up here because -2x squared times this x gives me -2x cubed. But I'm not just multiplying it by x, I'm multiplying it by x minus 1, so I'll also get a plus 2x squared, and then I'll subtract. This goes away, -2x squared minus positive 2x squared is -4x squared. Bring down the 10x and repeat. To get rid of this -4x squared, I'll throw a -4x up here because -4x times x is -4x squared. -4x times -1 is plus 4x. Subtract and you get 6x. Now you want to get rid of this 6x, so throw a 6 up top because 6 times x is 6x. 6 times -1 is -6. And when you subtract, you see you get no remainder, which is a good thing. No remainder tells me that x minus 1 divides evenly into this polynomial, which it better because if x equals 1 as a root, x minus 1 was supposed to be a factor. And if it's a factor, it's got to divide evenly in here. Anyways, the point of all this is we can now write g of x as x minus 1 times -2x squared minus 4x plus 6. Which is good, but it's not the factored form because we can factor this thing further. One thing we could do is pull out a -2 from this polynomial and write it as -2 times x minus 1 times x squared plus 2x minus 3. And now we can factor this. I just need two numbers that multiply to -3 and add to positive 2. How about positive 3, -1? So this, or -2 times x minus 1 squared times x plus 3 would be your factored form. All right, now we go down here and it says sketch a graph. Okay, so the important things to note is that we got x-intercepts at 1 and -3. Here's 1, here's -3. The multiplicity at 1 is even, so I'm going to bounce off the graph there, but the multiplicity at -3 is odd, so it's going to go straight through the graph there. Y-intercept, just by looking at this, I can tell it's -6. And that should be enough information to draw the graph, but as long as I'm here, I'll point out that the end behavior, as x goes to infinity, as you go to the right, this graph is going to go down. And as you go to the left, this graph is going to go up. And I get that from the fact that my leading coefficient is negative and the degree of the polynomial is odd. So we kind of start out up here, go straight through this point, go through this point, at some point turn around. Let me try to draw that a little bit neater. It's hard to draw on a computer. Whoa. So I'm coming down here, going through this point. At some point I'm turning around. You can have it turn around here if you want to turn around anywhere. We'll later figure out where it turns around when we take calculus. Comes up through this point, but kind of bounces off and heads back down. This is far from an exact picture of the graph, but it's close enough. It incorporates all the key information that we wanted in this. So we'll call that good and end this video here.